Hey guys, today in our grade 12 chemistry class, we are going to see how what we've been learning about acid-base chemistry and pH is affecting something that's a really big issue in our world right now, global warming. We will specifically look at how global warming is affecting our oceans from the perspective of chemists, since we're all chemists here. We're going to read an article called Acidic Seas: How Carbon Dioxide is Changing the Oceans by George Hale. Alexa adjusts her snorkel, mask, and fins as she prepares to plunge into clear blue water. She and 4 other U.S. high school students are 2 miles from Isla Belena, an island off of the Pacific coast of Costa Rica. The waters surrounding the island contain coral reefs that attract visitors from around the world. The students are attending Ocean Camp, a university-sponsored 2-week research program that exposes students to oceanography and marine biology. Here, Alexa and her classmates will learn firsthand about marine life, as well as check the health of the reefs and 18 species of coral. Along with her instructors and a snorkeling guide, the students swim past swaying tentacle-like coral polyps and colorful fish. All the while, they watch closely for corals that have faded color, or that seem to be weakened and crumbling. Alexa and her classmates have learned that these are signs of unhealthy corals, which are being threatened by warming and increasingly acidic oceans due to rapid changes in the Earth's climate. Although corals typically thrive in warm water, it places too much stress on them if the ocean gets too warm. This causes them to lose their beautiful colors and turn white as if they're being bleached. A more acidic ocean can also make it harder for the corals to get the materials they need to grow, and that causes them to weaken and to crumble. This is very concerning because although coral reefs make up less than 1% of the Earth's surface, they play a crucial role in the ocean's ecosystem. Corals provide shelter for perhaps a quarter of the ocean's species. This is why researchers study changing ocean waters and ask the important question: how will a warmer and more acidic ocean affect corals, and what does that mean for the health of our oceans? One of the lessons Ocean Camp instructors gave earlier that week covered climate change and how it affects the ocean. A culprit behind ocean warming and acidification is an increase in carbon dioxide in the atmosphere. Carbon dioxide and other gases play a crucial role in the Earth's climate, in what's called the greenhouse effect. Without them, the planet would be cold and inhospitable. Excess heat, however, is not just limited to air. Ocean temperatures have also increased, which affects coral reefs around the world. When water becomes too warm, corals can become stressed and they expel symbiotic algae living in their tissues. Without the algae, the coral loses its major source of food, turns white or very pale, and is more susceptible to disease. Carbon dioxide's effects on the ocean go beyond warming, though. The ocean has dissolved a lot of carbon dioxide, which keeps it out of the atmosphere. But as the concentration of carbon dioxide in the atmosphere increases, even more is added to the ocean, and it changes the water's chemistry. Gaseous carbon dioxide dissolves in the ocean's surface water to produce aqueous carbon dioxide. Carbon dioxide reacts with the water molecules and releases hydrogen ions, thus lowering the pH. Dissolved carbon dioxide reacts with water and dissociates into bicarbonate ions, or HCO3-, and the hydrogen ion, H+. Because the ocean is basic, it has a pH of about 8.2, the H+ concentration is relatively low. As a result, this equilibrium is shifted almost completely to the right. About 0.5% of the carbon dioxide is found in seawater as dissolved CO2. About 89.5%, is in the form of the bicarbonate ion. As a result of shifting the carbonate-bicarbonate equilibrium, the pH of the ocean is changing. Texas A&M University oceanographer Catherine Schaemberger says ocean pH has dropped from 8.2 to 8.1. Continuing to release carbon dioxide at the current rate will mean the oceans will continue to increase in acidity. These students have a lot to think about when they return home from Costa Rica. Over the course of 2 weeks, they have learned about how the ocean interacts with the overall climate and how human activities can affect ocean life. Future scientists will need to understand how pollution, warming, and ocean acidification affect marine life and come up with ways to reduce atmospheric carbon dioxide and its impact on our oceans. The students see that harmful ocean acidification affects coral reefs differently around the world, possibly because of the variations in pH or ocean chemistry. They learned how ocean water, seafloor sediments, and even Arctic and Antarctic ice are showing scientists that atmospheric carbon dioxide and ocean pH are changing faster now than ever in the past. Alexa and her classmates found out how increasing carbon dioxide in the air affects the ocean through changes in the carbonate and bicarbonate ion concentrations and pH, how those changes might affect coral reefs, and what that could mean for the rest of the oceans, as well as for marine life and human population. The lesson these students learned and activities they participated in, particularly their snorkeling tour of a coral reef, will give new perspective on oceans and oceanography.